The line spectra of the hydrogen atom was explained by the third postulate of Niels Bohr. We know that when an electron in a lower energy level with principal quantum number n1 absorbs energy from a photon, it jumps to a higher energy level, such that the photon energy will be equal to E2 minus E1, where E2 is the energy of the level corresponding to N2 and E1 is the energy corresponding to N1. Similarly, when an atom jumps from a higher energy level, E2, to a lower energy level with energy E1, a photon is released with the frequency nu, such that h nu is equal to E2 minus E1. Let this be equation 1. We have seen from Bohr's postulates that the energy En of any level corresponding to a principal quantum number n is given as En equal to minus m e to the power 4 by 8n square epsilon naught square h square. Now using the result of equation 2 for n1, the energy E1 is equal to minus m e power 4 by 8 n1 square epsilon naught square h square. Let this be equation 3. Similarly, for n2, the energy E2 is equal to minus m e to the power 4 by 8 n2 square epsilon naught square h square. Let this be equation 4. On substituting equations 3 and 4 in equation 1 and simplifying, we get h nu is equal to m e to the power 4 by 8 epsilon naught square h square into 1 by n1 square minus 1 by n2 square. This equation is called Rydberg's formula. Let this be equation 5. From equation 5, we get nu is equal to m e to the power 4 by 8 epsilon naught square h cube into 1 by n1 square minus 1 by n2 square. Let this be equation 6. Substituting n1 is equal to 2 and n2 is equal to 3 in equation 6, we get nu is equal to m e to the power 4 by 8 epsilon naught square h cube into 1 by 2 square minus 1. From equation 6, comparing nu with the empirical formula for Balmer's series that you have learnt earlier, we get nu is equal to Rc into 1 by 2 square minus 1 by n square. Hence, we see that the value of R, or the Rydberg's constant, is equal to m into e to the power 4 by 8 epsilon naught square h cube c. Substituting the values of mass of the electron m, charge on the electron e, permittivity of free space epsilon naught, Planck's constant h, and speed of light c, we get R is equal to 1.03 into 10 to the power minus 7 per meter. This value of R is very close to 1.097 into 10 to the power minus 7 per meter, which is obtained from the empirical formula of Balmer. This agreement between the theoretical and experimental values of Rydberg's constant provided a direct and striking confirmation of the Bohr's model of the atom. So, when we substitute n1 is equal to 2 and n2 is equal to 3 4, 5, and so on, we get the Balmer series. Similarly, when we take n1 is equal to 1 and n2 is equal to 2, 3, 4, and so on, we get the Lyman series. When n1 is equal to 3 and n2 is equal to 4, 5, 6, and so on, we get the Paschen series. When n1 is equal to 4 and n2 is equal to 5, 6, 7, and so on, we get the bracket series. Similarly, when n1 is equal to 5 and n2 is equal to 6, 7, 8, and so on, we get the Pfund series. In this diagram, it is clearly seen how different atomic series are produced when electrons jump from a state of higher energy to a lower one. These lines are called emission lines. Likewise, absorption spectra is also obtained when an atom absorbs a photon having an energy equal to the difference in energies of two levels, and it makes a transition from the lower energy level to the higher one. This is called absorption.
दोस्तों, यदि आज की वीडियो आपको अच्छी लगी हो तो लाइक कीजिए, चैनल को सब्सक्राइब कीजिए और अपने दोस्तों के पास इस वीडियो को शेयर कीजिए। अगर आपका कोई कमेंट हो तो कमेंट बॉक्स में नीचे जरूर लिखें। थैंक यू।